Today we're going to be learning about 3 of the important theorems that we learn in calculus. Does everyone remember the first one?
Limit.
No, IVT, the intermediate value theorem. But today we're going to do 3 more and learn how to find absolute extrema on an interval. Okay? So, we're going to call this extrema and other important theorems. Okay, and we're going to start off with the EVT. Any guesses what EVT stands for? Extreme value theorem. There are several things that have to be true in order to do an extreme value theorem. The most important is that f of x must be continuous on the interval a to b. Notice that's a closed interval, okay? The endpoints have to exist for this to work. If you have an asymptote or an open circle, EVT goes out the window, okay? So, here's my little graph. Because you know when I do theorems, I always draw a graph. Yeah. And I'm going to draw some continuous function. We're going from A to B. This is f of A, and there's f of B. Okay? And the only thing that has to be true about this function is that it has to be continuous everywhere on the interval, including the endpoints. All the extreme value theorem says, somewhere on the interval, there must be a high point. And somewhere on the interval, there must be a low point. There has to be an absolute max and an absolute min. For this problem, this is my absolute min. Do you agree with that? Yeah. Lowest point on the graph. So f of A is less than or equal to all other values on the function. F of A is less than or equal to f of x. So far, so good? Where is the absolute max? Is it f of B? Is that the highest point? No. It could be, but in this case it's not. Is that the absolute max? No, that's what we call a relative min, okay? Because for that location, it's the lowest point, but it's not the lowest point for the entire function. What about that one? Yes. And we're going to call that C, so that's going to be f of C. So we're going to say less than or equal to f of C. Now, why do you think it has the equals on the inequalities? Is it possible that the absolute max could be the same as the absolute min? What kind of a function would that be? A horizontal line. If you have a horizontal line, all of the y values are the same. But it is a continuous function. And we would just say that the absolute max is the same as the absolute min. It still has a highest and a lowest. They're just the same. Okay? That's the only reason we need the inequalities with the equals. Okay? So that is the extreme value theorem. But how do we find them? function. F of x equals 3x squared minus 2x plus 1. Find the absolute extrema on the interval (0 to 5). So, what is this function? It's a parabola, it's a quadratic, and we're only going to look at the part of the graph between 0 and 5. Because we know what this looks like, we could do some basic algebra and find the extrema, but we're going to use calculus to find it. Okay? So, we do what's called a candidate's test. And the candidates for absolute extrema are the endpoints and any relative extrema. Okay? So we're going to check endpoints and what we call critical numbers. Now, critical numbers is a new term for us. We've never used that term before. Bless you. Critical numbers are anywhere where f prime equals 0 or is undefined. So, do I know my endpoints? What are my endpoints for this function? 0 and 5. But do I know the critical numbers yet?
No.
How do I find them?
Set equal to 0.
Set the function equal to 0?
The derivative.
The derivative. So I'm going to take the derivative, which is 6x minus 2. Right?
Yeah.
And then I am going to set that equal to 0. So 2 equals 6x. X is equal to 1/3. Is 1/3 on the interval? Yes. What if it wasn't on the interval? Do I need to look at it if it's not on the interval? No, because I don't care. Then I would only look at the endpoint. Okay? Now what do you think I'm going to do with those to determine the highest point and the lowest point?
Plug it into the original.
Plug them into the original because the original is position. Okay? So when I plug 0 in, 0 minus 2 plus 1 is 1. Okay? When I plug 5 in, 75 minus 10 is 65. Plus 1 is, that's probably going to be my max. Here, when I do the 1/3, I'd get 3 times 1/9, which is 1/3. I'm going to write this one out because I can't do it in my head quite as much. Minus 2/3, plus 1, which is 3/3, right? Did I do all that right? I think so. So negative 1/3 plus 2/3 or plus 3/3 is, okay, so what is my maximum value? What is my minimum value? 2/3. Now, you have to be very careful about the wording. Sometimes they will ask for the max and min. And if they ask for the max and min, it's just your y values. But if they ask where it occurs, that's the x value. Okay? So you have to make sure that you're answering the question. So how do we feel about the candidate's test? What would make this process harder? Harder derivatives and messier numbers. But other than that, it's the same process. Yes, ma'am.
Why didn't she look for the undefined? Like,
There's nowhere that a line is undefined.
oh, okay. I forgot.
That's going to mainly happen when you have a numerator and a denominator.
So it's a fraction.
So then wherever the denominator is 0 is where the function is undefined.
Okay, so that depends on the derivative.
Yes. Okay? You're going to look for sharp corners, like if you had an absolute value or something like that, and you're going to look at denominator 0. Okay? How do we go? Yes.
We're not understanding why you had to find 1/3 again. Can you kind of explain
Okay.
that again?
Let's think about a normal graph. Okay? I'm just going to draw one. Okay? Are we ready? Here's my graph from here to here. Okay? What we've got is an absolute min here, right? But this endpoint was not the absolute max, because there are other high points on the graph. Okay? Anywhere that we have a little hump, we have a relative extrema. Those could be higher than the endpoints or lower than the endpoints. Well, what's the slope at that high point? 0. And what's the slope at the low point? 0. So those critical numbers are places where the graph is turning. And if the graph turns, it might be the highest or the lowest point. So you've got to check those other points to find out where the highest is. Come on in. Thank you.
And so we
Goodbye,
we're
Mr. Lacan.
finding, we found 1/3.
I pronounced it wrong, I know. I apologize. You're going to be on YouTube forever. Yes, Lenore.
So we found that extra point by plugging in the x values that we got on our interval into the derivative of the original equation.
Well, what we did is we found the critical number, right? Sometimes there's more than one, but we plug those critical numbers back into the function, and then we compare them. The lowest is the minimum, and the highest is the maximum. And that's it.
Okay.
Okay? Let's do one more of those. Okay? And then we will move on to the other theorems. Next class, we're going to be learning all about the relatives. Today, we're focusing on the absolutes. Okay. Let's do one that's not going to turn out quite as nice.
Can you do it with like an undefined?
That's what I was doing. Okay, ready? This time my function is going to be let's do x minus 1 over x plus 1. Okay? And we're going to do on the interval 0 to 3. Okay? So, we're going to set up our candidates test. We know we're going to check 0 and 3 because we have to check endpoints. Because the endpoints could be the highest and lowest. We just don't know. How do we find any other possible extrema? The function or the derivative? Okay, so f prime of x equals. What are we going to have to do with this one? Quotient rule. So x plus 1 squared, right? And then bottom